You're very welcome back. Now, if you've ever wanted to learn how to make a lava lamp or why water can change colour, then look no further.
We're joined by Anika Fuchs from Junior Einsteins and Placeable, who's going to show us the science behind it. Good morning.
Good morning, guys.
Hello.
We're going to make a giant mess here this morning.
I hope so, because
Excellent.
mess is always fun,
guaranteed.
isn't it?
Tell us about Junior Einsteins, first of all. What is it?
Junior Einsteins, we're a science education company. We want to make science more fun for kids, mostly in primary school age, promote science education in schools, also in private settings, festivals, corporates. Like, we go wherever kids are and try to make science fun, engaging, and
It's about making it a little bit entertaining for them.
Exactly.
You say it's engaging them, getting
and to
their
show
interest.
them that science is not just formulas that you need to kind of memorize. There's more to it. Because often kids don't get exposed to science till secondary level, and we think that's too late. So we want to kind of.
And it used to be all textbooks, wasn't it? And very little kind of demo, practical, interactive
so we want to
stuff.
get their hands on. We want them to get a bit messy, and to enjoy themselves.
Let's get our hands on and get messy then. What are we making? What are we going to do?
First, we are going to do lava lamps. So that's based on a principle out of physics. It's called density. So if you ever tried at home to mix water with oil, you might realize that's not going to happen. They kind of stick on top of each other.
They separate,
So to do lava lamps, we start with glass jars. You guys can use whatever you have at home. Fill that with 1/3 of water.
Okay.
Pass that on to you guys.
Okay. Now, obviously, if children want to do this at home, they need supervised play with adults there.
Exactly, especially when you use glass, it's always a risk of breakage.
Of course,
something like that.
Yeah.
Brilliant, thank you guys.
Water done. What's next?
You can choose your colour, red, green or yellow.
I'll go with red, please.
Lovely. Here, wait a second, that's actually the red.
Thank you very much.
Okay, yellow, please.
Yellow. So we add a few drops, guys, that's just food colouring.
Okay.
So you can choose whatever colour you fancy.
Just a few drops?
Just a few drops, and whatever you might have at home. Okay. You can see when you fill that in, it kind of colours strongly, and then we kind of just swirl it around. So far we have lovely coloured water.
Perfect. Okay.
It's like the wine slot now, isn't it?
It is, yeah.
You might not want to try that.
I wouldn't try that, Anna. No.
So, guys, and then I give each of you a bottle of just vegetable oil, very, whatever you have at home.
Okay.
And we basically fill that up to the top.
Okay.
So
just pour away?
Yeah, just pour away. When you fill it in, you can see it creates some kind of bubbles.
Look at that.
Yes. All the way up? Will I keep going?
Yeah, so you can leave a little bit of space at the top.
Okay.
So you see when you fill it in, it creates these lovely bubbles. But quite quickly, they will settle down. So the red colour will sink to the bottom. Here, the yellow one.
Very good.
Or, in my case, the green one.
By God, isn't science deadly?
Isn't it? So pretty. So, guys, so far we have just it just sits on top of each other, but we don't have yet a lovely lava
and with
lamp
the bigger
effect.
bubbles at the bottom.
So yes, they will settle a bit down. This is just at the moment because we poured it in, and in that process there came also some air.
So this is just
oil,
density.
right?
This is the oil is heavier than the water. It goes to the bottom.
The water is heavier than the oil.
You see?
Who would have thought?
Who'd have thought?
I was surprised at the beginning as well. But basically, yes, oil is lighter than water. If we would have now golden syrup, for example, put that in, it would sink to the ground.
Yes.
So it's about how heavy basically something is, right? How many molecules there are. So, but now
this is the piece of action.
This is the piece of action because we want to have a lava lamp effect. So we need to put something in there. So this is Alka-Seltzer.
Yeah.
You know when you put that in water, it fizzes up.
Yeah.
So the same thing happens here because to move the water back up into the oil, we need to have some kind of force to it.
Okay.
So we create some bubbles. They will transport the water up and the bubbles will also sink back down. So the color will move through the oil up and down. So guys, I give you each that's it, a
and
quarter.
What's in the Alka-Seltzer to make that action happen?
So there is a kind of acid in there. It's a bit like aspirin, kind of in that direction, that basically dissolves in water and fizzes up and creates some kind of gas bubbles that come up. So you just drop that in.
Drop it in?
Yes. It will sink to the bottom, and it takes a few seconds till it starts to dissolve.
And then kaboom!
And you can start seeing
bubbles.
exactly that bubbles will start moving.
Yours is broken.
And also will go and sink back down. It might be just because the yellowish is close to the oil.
Yeah, no, it's going.
But for the green and the red one, you should see quite nicely The upwards looks a bit like a stream, but downwards it looks really like the lava lamp bubbles that we have.
Yeah, it's cool.
A tiny bit smaller than in an original lava lamp, just because it's a different material. So if you do that at home, guys, it's really lovely when you put it in front of a candle or a lamp, and you can keep it in there with the lid on for a while and can add Alka-Seltzer every now and again and make it bubble up again. Because it will not go forever. When the Alka-Seltzer is dissolved, it will stop bubbling, but you can just like add it on again every few days. No mess.
Far too clean for your liking, wasn't it?
Disappointing, right? I try to keep
it's a great lesson for children to understand density.
Exactly. So it's something that they can look at and see like, yeah, actually it's true. Oil and water don't mix because kids, I mean, some of them might not have you cooked or, you know that, have tried that. And also, like, you can, like I said, at home, if you have honey or golden syrup, you can try what happens if you fill all of that in one container and see where they end up.
That will be heavier and thick.
Exactly,
okay.
Yes.
So
okay,
interesting.
guys.
So we're going to move on to cabbage.
Yes, we're going to move on to our cabbage indicator. This is basically this lovely pink liquid, which is made out of red cabbage. So I ended up cooking red cabbage this week.
Of course you did, yeah.
Smelly business. But you get this lovely pink liquid out of it.
Okay.
So, guys, it's really basic at home. You just cook that for about 10 minutes. You end up with a very dark purple liquid. And you dilute it about 1/3 of the cabbage liquid with the rest is tap water.
Okay.
So you need to get it a bit brighter because otherwise it will be quite dark.
Okay.
And why did I do that? Like, cabbage itself is nice, but of course I want to do it for some science reasons. So this one is about chemistry, about pH levels. You might have seen that when you buy your body lotion, it says it's pH neutral.
Yes.
So what does that mean? You know, it's like for kids a rather abstract concept to understand pH levels. So it has to do with acids and bases. So, you know, kids know acids, for example, from lemon juice or vinegar. So how do we know it's an acid? Because it tastes sour. But bases are a bit more difficult concept, like because often they are used in cleaners, so they are soapy, or would taste bitter. But obviously, you don't want to use everything and taste it. You know, it can be a bit dangerous.
This is a way of testing to see what.
This is a way of testing pH levels without having to eat it.
Of course, okay.
So because we don't want that. So I have here little test tubes already filled up with cabbage indicator water. You can see it's a nice light pink. And I have here different liquids. They all would be something that you find in your household at home. For example, vinegar, or like just water, baking soda, bicarbonate of soda, washing detergent. But literally, kids can test whatever liquid they find at home. If you want to test what pH level coffee, for example, have, or your lemonade, you know, there is no limit.
And why are you using this against cabbage water versus normal water?
Because the cabbage has a funny ability to change its color when we mix it with another ingredient. So, guys, I brought pipettes. So each one of you gets also one. And you can pick whatever you want to use from here. I might just go with that because it's a more trickier one.
Okay.
So you can pick any of these liquids and just like pipette a bit of that liquid into one of the test tubes, and we can see what happens to our cabbage indicator.
I'm going to go with the vinegar.
Vinegar, okay.
Lovely.
So just pops a few drops in.
Yeah, you can just like, you know, go for a...
Oh, one drop. Well done,
drop.
Simon. That's
you might
marvellous.
need a tiny bit more.
And will I go with the second one here with the lemon juice?
That's brilliant. I just start from the end. Because mine is a bit harder to dissolve, I just need to swirl it a little bit.
Are you happy for us to fill it up?
Yeah, that's absolutely fine. So you can see the lemon juice one already changes into some reddish color compared to the purple that we had at the beginning.
I'm not getting much out of this pipette.
This is no worries. I might assist with that in a second.
You need some help.
No, here we go.
You got it? He has the hang of it now.
Yay, very good.
So what colour should that vinegar do?
So that also turns reddish.
Yeah, it's
can you
going to
see?
be purpley. Yeah.
So that was the original color. So you can see that definitely
Tinged it
moved
slightly,
on.
yeah.
And what's that showing in terms of the scale?
So that shows like
Neutral is 7.
neutral is 7, right? Like for example, if we pour water, let's try that.
Okay.
I take the third one with water. So this one should not change because water is pH neutral, right?
Right,
So the
okay.
color is
Will
like
stay the
that
same.
here in
Very
the
good.
middle, right? When we see now, for example, your lemon juice one, that's definitely here on the reddish scale. So it would be somewhere possibly about a pH level of 2.
Very
so it's
good.
definitely an acid because acids are below 7 till 0.
Very good.
And the base, like you can see here, this one went into purple,
Wow.
darker purple, right?
And what was that? That was the washing detergent?
That was the washing
Right, very
detergent.
good.
So let's see what happens with the bicarbonate of soda. I put a bit of water in it because powder is just difficult to
Of course.
work with.
Ah, look, straight away.
So you can see that straight away went into a greenish color.
It's a great way of getting the kids engaged.
Isn't it? So,
see them
and
mess
this is
around with
really
this sort of stuff.
so much things that you just have in your house anyway, which you can, test and they can just and this is so easy made. And you don't need test tubes. You can just use glasses, cups, whatever you have at home. And then you basically can compare that with your pH scale to see okay, we are moving here. So if I would sort that, this would be a stronger acid than this. Then we have a neutral, and then we move into the
Into your
base
bases.
section.
Kids
So
love
it's a
that.
really nice concept. Yeah.
Thank you, Anika.
Well, thank you. It's an
Thank you so much.
education.
It is.
Where are you this weekend?
We are this weekend at the Playstival at the Airfield Estate to bring science fun to kids. So guys, come and visit us. It's going to be amazing. Also,
Bring your
lovely food.
cabbages.
Yes.
Bring your cabbages.
They'll learn and they'll have fun, right?
They will, absolutely, yes.
Thank you very
Right,
much.
lots
Thanks
more
so
still
much.
to come, folks. Stay with us. See you in a few minutes.